I bought today a box of oranges coming from Spain, and I have salvaged the multiplex, etc, etc. But the more interesting thing was that this box was, say, held together with a kind of iron pins, and that made me more or less curious. And here you see all these iron pins here, with which that wooden box to transport oranges was made. And I was very curious whether this say iron or steel, whatever you like, there are of course completely different properties regarding to steel. For instance, here this thing, a drill, hardened steel, and here we have a transformer. You can see all the laminated, say, parts of steel of which the transformer was made, and it's important to tell, for instance, that all these iron laminated parts here are isolated in an electrical way to prevent that such an iron core gets a kind of massive steel block that does not react properly on the changing electromagnetic field. Especially on the lower frequencies, say 50 Hz, 100 Hz, 300 Hz or whatever. And when you take such a transformer apart, you can measure that. Of course, there are many other, say, magnetic materials used in electronics. For instance, here ferrite cores. They work in general better on the somewhat higher frequencies, say between 20 kHz and even to, say, 30 kHz. They often have color codes to indicate where they work. Anyway, that was a kind of side pass. The circuit again. In fact, it's a Darlington that has on its collector lead a coil. And in this case it is this coil. The windings are 40 windings on the primary, 40 windings, so together 80 windings, and 100 windings on the secondary. And I was very interested, like I told, about the, say, electromagnetic properties of the steel wires that were used in this orange cradle in a certain way. Made with triplex, so wood, and this was all, say, cramped together with steel pins. So I made an oscillator, and this is, say, the most easiest oscillator to test such a situation. Made with 2 transistors. I use now a BC549C, but I'm more or less absolutely sure that it is better to use the BC547B, because these 2 transistors have a very high amplification factor. In fact, a little bit too high. for such an application as I show here. Windings of the coil, perhaps you can get kind of insight how that coil was made. Well, the circuit is here again. It's a Darlington circuit, and it gets to oscillation when we mount a capacitor going from the secondary to the base of the first transistor. This is, by the way, a kind of universal circuit with which you can get all kinds of coils, even with a low quality factor, into oscillation. And here we see that oscillation. It's a sine wave now on, say, 800 kilohertz, and I surely have to say that that is purely accidental, that it makes a sine wave here. Could also be a kind of very distorted wave. Has perhaps also something to do with the voltage to which the oscillator is connected. So let's do a small try. Now it's 2.2 volts. We go to 2.9 volts and 3.3 volts, and now I stop this experiment because I know, I've tested that these transistors get very hot. So when you want to make such a circuit in a kind of application where you need current here, use here a transistor that can handle that current, for instance a BD139. Anyway, here the circuit again. And here the transistor that I use, but I advise to use another transistor. And I've tested where that circuit works, and my counter and scope tells me that it is on 968 kilohertz, and that's true. This shows that I don't have a, say, audible frequency anyway. So the conclusion is afterwards that, for instance, all these, say, pieces out of that orange box work in a certain way very good for this high frequency. When this was, for instance, a kind of massive steel wire, and I've done many experiments with that, I would surely not go to this high frequency. So, has of course everything to do with the isolation in between of all these steel pins inside that coil. That makes that such a steel core reacts in a completely other way compared to a massive steel core. It can more easily follow the frequency variations due to the fact that all these steel pins are isolated from each other. Anyway, that was something to tell about this circuit. And I have here a sine wave, not by a certain purpose, but anyway, the whole circuit here is a quite good circuit to do experiments with, also with other types of coils, with a lower quality factor or a higher quality factor, with a ferrite rod core, or with, say, such a ferrite cylindrical core. It doesn't matter, and this is a good idea, a good first idea to get such a coil into oscillation. And of course, when the windings of the primary and the secondary are different, you get a different voltage out. So Ohm's law is valid, and so here for instance 12 volt at 1 ampere, and here for instance 200 volts, but in that case the current will go down, and of course there's loss in such a transformer and in such a coil, say energy loss. That's completely logical, refers to the standard electronic theories, etc., etc. So that was more or less all to tell. Thanks for watching.